Good afternoon, everyone, and thank you for joining us for today's webinar. All right, let's see. Okay, so good afternoon, welcome, and thank you for attending today's webinar as a part of Chagrin River Watershed Partners Winter Webinar Series for the 2023 to 2024 season. My name is Chris. I'm an AmeriCorps service member serving as the Watershed Steward at Chagrin River Watershed Partners. This is the 9th webinar as a part of our series, where CRWP partners with environmental professionals to deliver educational presentations to other interested professionals and members of the public. We have been and will continue to promote this series through our e-newsletter, social media pages, and our website. If you're interested in learning more about this series, feel free to check out our website and sign up for our last webinar, which will take place next Thursday, March 21st, where the environmental nonprofit Ducks Unlimited will present on their work in Northern Ohio and the power of partnerships and conservation. If you have any questions, feel free to type any as we go in the chat box on your screen, and we can cover them at the end of the presentation during the Q&A session. Just to let you know, today's presentation is being recorded and will eventually be uploaded to our YouTube page. In my follow-up email, I will include a link to this recording so you can review it at any time. In addition, I will also include a survey that helps Chagrin River Watershed Partners prepare high-quality webinars for the public and environmental field at large. A PDF file of today's presentation will be made available on the GoToWebinar portal and will also be uploaded to our website in the coming days. For today's webinar, Ross Shaw and Zak Allan from the Great Lakes Fishery Commission will present on the invasive sea lamprey in the Great Lakes ecosystem. Their presentation will include the history of how this invasive species entered the Great Lakes Basin, the impact the sea lamprey has had on Great Lakes fisheries, along with the introduced control program and eventual recovery of the fishery. They will then discuss how this invasive species is still a constant threat to the Great Lakes ecosystem and how their control ended up being one of the most successful aquatic invasive species control programs in history. And with that, I'm going to turn it over to Zak and Allan, and welcome, guys.
Thanks so much. And I will share my screen here. Let's see, can you all see my screen?
Yes.
Perfect, okay. Yeah, so let's get started here. So before we start talking about how bad sea lampreys are and the destruction that they cause in the Great Lakes, I do like to start off our presentations by talking about lampreys and their native ranges, because lampreys are a very important species to many ecosystems around the world. So for example, here in North America, we have the Pacific lamprey on the west coast of North America. We have actually 4 native lamprey species here in the Great Lakes. So you can see all 5 species here. So you have the sea lamprey, the invasive sea lamprey, the American brook, our native lampreys, are one of our 4 native lampreys, the American brook, the chestnut, the silver lamprey, and the northern brook. And as you can see here, the sea lamprey is significantly larger than any of our native species, and that's part of the reason it's so destructive here in the Great Lakes. So in addition to the 4 native species here in the Great Lakes, we do have sea lampreys are native, of course, to the Atlantic Ocean, where they are a very important species culturally to many places, especially places like Western Europe, where they're considered very valuable for their food fish. So you can see, I believe the traditional way to prepare them is in a stew. I've never had them. They don't really look appealing to me, but maybe I've just had them prepared the wrong way. And so what are the importance of native lampreys? So they're what we call ecosystem engineers. So they serve a number of different functions that are very important to the functioning of an ecosystem. So for example, the larvae, as we'll touch on later, what they do is they burrow into the stream bed, and by doing that, they're actually going to aerate that stream bed and provide vital oxygen to many of those organisms that are within the stream bed. They're also filtering water throughout that larval phase. They act as a food source for a variety of organisms all throughout the different phases of their life cycle, and they transport nutrients up into rivers and streams when they run from the lakes and ocean up into the rivers and streams and die those nutrients that are in their body are very important when they're returned to that river or stream ecosystem where they're spawning and dying. And then they're very culturally important, like I mentioned, in Europe for their food, as well as indigenous folks, especially out west. So these both of these images came from the Columbia Intertribal Fish Commission, which is out west, where they are working to try to restore runs of Pacific lamprey, which are very important to many of the indigenous groups out there. So now that we've talked about the lampreys in their native ranges, let's talk about the one lamprey species that is actually invasive in the world. So of the more than 80 species in the world, 80 lamprey species in the world, the sea lamprey is the only invasive lamprey species in the world. So how did they get here? So they came from the Atlantic Ocean, and they came in through the man-made shipping canals up through here. They were only in Lake Ontario for about 100 years. And that was because Niagara Falls served as a natural barrier. So it wasn't until 1919 when the Welland Canal was widened and deepened to allow ships to bypass the falls and bring more goods and services to the rest of the Great Lakes that the sea lampreys were able to get around. So once the Welland Canal was widened and deepened in 1919, that allowed the sea lampreys to get around Niagara Falls and get into the rest of the Great Lakes. And so by 1924, they had invaded Lake Erie, and then by 1938, they had completed the invasion, reaching Lake Superior. And when they invaded, the sea lampreys were a absolutely destructive invasive species. And part of that was because the Great Lakes fishing industry at the time was a much more integral part of the economy. So your commercial, your recreational, and your tribal fisheries were a much larger part of many communities back in the day than they are today. So for example, many coastal communities relied on commercial fishing. So I believe this is in Erie, Pennsylvania, where you can see all of these commercial fishing boats that were a huge part of the coastal community's economy there. One particular area, one particular fishery that was very hard hit by the sea lampreys invasion was the commercial lake trout fishery. So lake trout was a very viable fish to catch and sell back in the day by commercial fishermen. It was lake trout and whitefish were kind of the two big fish that were particularly hard hit by sea lampreys. Lake trout in particular, as they are actually the sea lampreys' preferred host species. So they were absolutely devastated by the time sea lampreys invaded and really got a grip on the Great Lakes. So as you can see from this graph here, lake trout populations fell to near zero here in the Great Lakes. In fact, they were extirpated or eliminated from 4 out of the 5 Great Lakes. The only lake where lake trout actually remained was in Lake Superior. And that's because it was the last lake where sea lampreys invaded, but also the first lake that we started sea lamprey control upon. So the commercial lake trout harvest was absolutely devastated from the sea lampreys invasion. To kind of put this in perspective, at their peak, the sea lampreys were killing more than 100 million pounds of fish per year. And to put that in perspective in terms of the commercial harvest, that was more than 5 times the commercial harvest. So they were doing a large damage on the commercial fishery and the lake trout populations. So you may be curious if you've never seen a sea lamprey before, well, how exactly do they do this damage? Well, they use this sucker mouth to latch onto the side of fish and drink the fish's blood. And before we get into that, I do want to make the important caveat that you can swim in the lakes without fear. So because we are warm-blooded creatures and fish are cold-blooded, sea lampreys are not actually going to feed on us. So unlike this very sensational magazine cover from back in the day, sea lampreys actually do not feed on humans because we're warm blood and they only prefer the cold-blooded fish. So how do they feed? So they use that suction cup mouth. So their mouth has 3 parts. So they have the outside of their mouth acts like a suction cup, allowing them to fix onto the side of the fish. They have over 150 teeth that line the sides of their mouth. And then in the middle of their mouth, they have the file-like rasping tongue. So they use that to suction onto the side of the fish and use that rasping tongue to bore a hole into the side of the fish's flesh. And so when the sea lampreys first invaded, the Great Lakes the management of Great Lakes fisheries was very piecemeal. So there are a lot of different jurisdictions around the Great Lakes. So we have 2 nations, the US and Canada. We have 8 Great Lakes states, 2 tribal entities on this side of the lakes, on the US side of the lakes, 2 provinces, as well as other tribal entities over in Canada. With all of those different jurisdictions across the Great Lakes, and much of the management at that time being very piecemeal, where say Michigan would manage their fisheries much different than without talking to say Wisconsin, for example, even though they both shared Lake Michigan. When the sea lampreys first invaded, what the nations of the US and Canada realized is that they weren't going to be able to continue to manage fisheries, and particularly attack the sea lampreys in this piecemeal way. And so what they needed to do was form an organization to overcome all of these different jurisdictions and kind of supersede all of these jurisdictions and come together to fight the sea lamprey. And so that happened when the US and Canada came together to sign the 1954 Convention on Great Lakes Fisheries, which formed the Great Lakes Fishery Commission, our organization. In that convention, the commission was established, and we were outlined with 3 major duties: conduct science, control sea lamprey, and coordinate fishery management. For the purpose of our talk today, I'm going to be focusing only on sea lamprey control, but if you have questions about our duties in conducting science or coordinating fishery management, feel free to let us know in the question and answer period, and we'll be happy to answer your questions there. So before we talk about sea lamprey control, we need to kind of get an understanding of the sea lamprey's life history. So we'll start when the sea lampreys are spawning. So sea lampreys are kind of like salmon in that they are going to run upstream to spawn. So what they'll do is they are going to, you can see from this little graphic here, the river is going this way. So they're going to run from the lakes up into the rivers and streams to spawn. So what they're going to do is they're going to use that sucker mouth that I pointed to earlier, and they're going to suction onto rocks and make a horseshoe-shaped nest. So they're going to suction onto rocks, make a little horseshoe-shaped nest, and then once that nest is created, they're going to intertwine with one another. One sea lamprey is going to latch onto the rocks, the other sea lamprey is going to latch onto that sea lamprey. They're going to intertwine, and then they're going to release their eggs into that nest, eggs in the spur. The females are very voracious reproducers, so each female will lay up to 100,000 eggs. To give you an idea of what that actually looks like in the body of a sea lamprey, here is a dissected pregnant female sea lamprey, and you can see that their whole entire body is just eggs. They've devoted pretty much all of their energy at that point in their life to producing eggs. And that's because, like I mentioned, the sea lampreys are going to die after they spawn. So it's an evolutionary, their evolutionary strategy is such that they are going to make as many offspring as possible. And because they're going to die afterwards, they're just going to make as many offspring as possible, and then whatever survives, survives. So in fact, of the 100,000 that they produce, only about 10% survive, which normally would be not that great of a success rate, but when you're producing 100,000 eggs, it is a pretty good success, and enough to very well produce enough offspring for the next generation. So then the sea lampreys will hatch from their eggs, and they'll turn into what we call larvae, or sea lamprey larvae, or the specific term in the sea lamprey world is amices. So sea lamprey larvae will live in the stream for anywhere from 3 to 5, sometimes to as many as 10 years. This is the longest stage of the sea lamprey's life cycle. And what they'll do in this stage is harmlessly filter feed in the stream bed. So you can see they've swam downstream a little bit, and all they're going to do is they're going to stick their little heads out, and they're going to filter feed using their mouths. And if you notice here on the illustration, the sea lamprey larvae have no eyes. So at this point, they're very primitive creatures. They're just filter feeding, and again, they're essentially harmless. However, they will, at one point, they will metamorphose, similar to how a caterpillar metamorphoses into a butterfly, and they're actually going to grow eyes and that sucker mouth. So if you take a look at the illustration here, you can notice they go from no eyes to eyes, as well as a pretty primitive mouth to that sucker mouth that I just told you guys about. So here's a good look at them. They are essentially what an adult sea lamprey looks like, but just in a smaller form. And that's where they are going to begin their parasitic phase. So they're going to go out to the lakes to start feeding on fish. So they will enter the lakes and feed on fish for anywhere from 12 to 18 months. And this is, of course, the phase of their life cycle where they cause the most destruction. So in this 12 to 18 months, they're going to kill about 40 pounds of fish. It's estimated that about 6 out of every 7 fish attacked by sea lamprey end up dying. And that's because they leave pretty nasty wounds. So if that fish doesn't die while the sea lamprey is directly attached, that wound that it leaves will oftentimes get infected and cause that fish to die. Or simply by having that wound, that fish is going to be more susceptible to predation. And like I mentioned earlier, sea lampreys they have their preferred prey species of lake trout, but they will feed on just about anything they can get their mouths on. So you'll oftentimes see them on lake trout, salmon, other larger fish, like we've seen them on fish as large as sturgeon, pike, to as small as perch, walleye, or bass. So no matter the size, as long as sea lampreys can get their mouths on and feed on their blood, they're going to feed on just about any fish they can. And now I'm going to turn it over to Zach here to talk about the major sea lamprey control methods.
Thanks, Ross. Yeah, I'm going to get into the control methods, especially the lampreycides, in quite a bit of detail, so bear with me, and if you do have questions at the end, please ask. So in our efforts to control sea lamprey populations in the Great Lakes, we employ 3 main methods. The use of lampreycides is kind of the main method, the utilization and construction of barriers or dams, and the deployment of traps. So each of these plays a crucial role in our integrated approach to manage this invasive species. So the work is carried out by the Great Lakes Fishery Commission in partnership with the U.S. Geological Survey, the U.S. Fish and Wildlife Service, Department of Fisheries and Oceans Canada, and the U.S. Army Corps of Engineers. They're all committed to protecting the Great Lakes fishery. So in our ongoing efforts to control sea lamprey populations, excuse me, I've got a little bit of just getting over a little bit of a cold. Agents from the U.S. Fish and Wildlife Service and the Department of Fisheries and Oceans Canada administer lampreycide treatments in selected Great Lakes tributaries each year. The treatment season begins typically around April, early April. It extends until late October, sometimes into November, depending on water levels and temperatures. Lampreycide treatments are conducted in Great Lakes tributaries with a 90 to 95% effectiveness. Without treatment, as Ross was discussing, these larvae would metamorphose into the parasitic juveniles. They develop their eyes along with their distinctive oral disc mouths, full of teeth, their rasping tongues, and they'd head out into the lakes and start feeding on their valuable fish species. So the first step to treatment is determining where treatments are needed. Larval assessment teams head out to river systems with backpack electrofishers. You can see on the picture on the left there, person's conducting an assessment to survey the abundance of larval sea lampreys and their stream distributions. Because otherwise you'd never know they're there, kind of like Ross said, they're kind of just hiding in the muck with their little heads poking out. So based on these surveys, recommendations are made on where to apply lampreycide upstream of the larval distribution in a river. So on the right, you see some very young sea lamprey larvae that were collected using this survey method. And then a stream ranking system is then used to dictate which streams will be treated and when. Next slide, please, Ross. So as you can see here, there's a vast number of tributaries where sea lamprey larvae have been detected, with well over 400 known to house sea lamprey larvae. About 250 are treated on a regular cycle to inhibit the chance of parasitics making it out into the lakes. Treating every sea lamprey producing stream, as you can see, is not very feasible, so streams are carefully selected for treatment each year, depending on larval size and density, minimizing the number of parasitic lampreys entering the lakes on a cost per kill basis. Next slide, please, sir. So once we've identified the systems to be treated each year, the next step is for our treatment crews to hit the road and start what we call pre-treatment work or pre-treatment data collection. This involves collecting and analyzing water samples, measuring flow levels throughout the system, engaging landowners for river access, and establishing suitable application points to treat from. So we're looking at a few key factors here. Reading the precise pH and alkalinity of the river water is crucial because those levels determine the concentration of the lampreycide we need to apply for maximum effectiveness. You can see that pH probe in a water sample in the one picture on the left there. Water temperature and dissolved oxygen levels are also determined because those levels affect how sensitive sea lampreys are to the lampreycide. And stream discharge measurements tell us how fast the treatment block will move through the river system and how much lampricide will be needed for a successful treatment. You can see that in the one photo, the field staff using a standard flow meter and a tape, measuring tape to determine the width of the stream. So they conduct that in segments. So these factors can also influence the likelihood of non-target mortality, is why it's important. For instance, if we see extreme fluctuations in pH, high water temperatures, or low levels of dissolved oxygen, for example, the risk of affecting other species increases. So that's why this preliminary work is so important. It helps us minimize the impact on non-target species and ensures the success of a treatment. If conditions aren't desirable, if it's the pH fluctuations are too crazy, or there's not enough water, or it's too warm, the treatment will be deferred to a later time when it's more suitable. Next slide, please. So now, when all these boxes are checked and the weather cooperates, it's time for treatment. So the lampricide we use is a yellow liquid. It's called 3-trifluoromethyl-4-nitrophenol. It's a mouthful. We call it TFM. It's a selective pesticide that targets lampreys, effectively killing them, while most other organisms can pass it through their systems unharmed at the low levels that they're applied in. The operation starts with our agents setting up what we call feeders. These are peristaltic pumps that push lampricide through silicone tubing, and they pump it out through a perforated hose, typically stretch across the width of the stream to ensure that the TFM mixes quickly. You can see on that upper left, you can see how that lampricide coming out all those holes. So not far downstream from that, it'll be a pretty even mix within the water column. Having a good mix is essential for determining accurate concentrations downstream as soon as possible. So applying from waterfalls, riffles, rapids, dams is a great advantage if that's possible for obtaining that mix really quickly. So once the feeder or pump is turned on, initial samples are taken downstream to analyze the concentration being applied using specialized equipment. You can see a kind of the field portable version of a spectrophotometer down on the left there. It's a pretty fancy piece of equipment. The concentration of TFM is adjusted by the feeder operator based on its concentration. So at regular intervals, every half hour usually, over a 12 to 14 hour treatment duration, water samples are taken and analyzed to ensure that the proper concentrations are being applied. The feeder operators also take routine measurements of how much TFM is being applied per minute. You can see there in the picture on the right, Teresa I work with there, taking a feed check, we call it. The concentrations are measured in parts per million. So we aim to affect sea lamprey larvae with minimal impact on other organisms, of course. Over application, if you were to just dump it in, would lead to non-target mortality for sure. But while not putting enough in would render treatment ineffective, it wouldn't do anything. Next slide, please. So for some larger treatments, liquid balicide, it's a different form of lampricide that's used in conjunction with TFM. So it's kind of a tandem operation. The combination increases the effectiveness of TFM greatly and can greatly reduce the treatment costs, as TFM itself is quite expensive. Unlike TFM, which I mentioned is applied in parts per million, the liquid balicide is applied in parts per billion. So this requires an extremely specialized device called the HPLC. It's a high-performance liquid chromatography device. You can see an agent injecting a sample into that crazy thing. It looks like someone made in their basement, but I assure you it's quite high-tech and very expensive. So you can see an agent doing that. So they also, in smaller tributaries, we use TFM in its solid bar form. You can see in the picture to the right, someone's putting some bars into a small trib, and the stream discharge of a small tributary like that will determine how many bars are used. Typically, it's 4 bars per part per million of desired concentration. So also during a treatment, an important effort known as secondary applications takes place. Agents, whether they're on a motorboat, they're in a kayak, or they're on foot, walking in chest waders, they'll seek out backwater areas and large puddles, essentially places where the lampricide isn't gonna get to, where there's suitable habitat, that mucky substrate where there's bound to be sea lamprey larvae buried in there. So they'll give it a spray, and I've seen it myself. They'll often come up and it'll look like spaghetti coming up out of a puddle. It's pretty gnarly. So during their effort, these secondary applicators also perform collections of lamprey larvae to measure for different year classes, whether they're those little ones we saw on the slide before, those would be like 1 or maybe 2 years old, or whether they're getting large and we're eliminating them before they metamorphose. So this helps assess the success of a treatment and provides valuable data for future control. All the agents with the U.S. Fish and Wildlife Service and Fisheries and Oceans Canada are well trained. They're licensed pesticide operators, and precision is the name of the game when we do this, and it just gets better every year for sure. Next slide, please. So in this animation, you can see a typical treatment process, kind of what it would look like. The main application of TFM begins far up in the river system. As it works its way down, TFM is applied to smaller tributaries along the way. This is done either because those tribs will contain larvae themselves, so it's kind of its own treatment, or it's used to cover off potential escapement for larvae that are activated during a treatment. So they'll come out of their burrows and they'll try to find fresh water, and if there is some, they'll hide out in there and they'll survive a treatment. So efforts are made to avoid that. Excuse me. An important part of pre-treatment, which I didn't mention earlier, and if you're near a treatment, but during pre-treatment activities, you might see it, is conducting flow timing studies. These studies often use it's an orangey red, pretty alarming looking dye. It's benign vegetable-based dye to help determine the flow timing through the system. So that ensures that the feeders on those smaller tributaries that you saw in that animation are synchronized with that main river's treatment block. Next slide, please. So this is another main lampricide that we use, particularly in lentic areas where TFM isn't feasible. It's called granular balicide. So I mentioned the liquid formulation of balicide used in conjunction with the TFM, but this is granular balicide on its own. It's applied from a state-of-the-art spray boat. The granules sink down to the lake or riverbed and they dissolve, which is lethal to the larva inhabiting the riverbed or the lake bed if it's around the mouth of a river. The St. Mary's River around Sault Ste. Marie is a prime example of a giant river system that is a big producer of sea lampreys that you can't treat with TFM. It's just not possible. Also, to conduct larval assessment in areas like this, instead of backpack electrofishers and doing this by foot, they have a large electrofisher that they put down from a vessel by a boat, and they do it that way. Next slide, please. So this is kind of a sensitive thing to talk about, but it's important to address the topic of non-target mortality resulting from lampricide treatments. So while lampricides are quite selective and target primitive systems of sea lampreys, there are also species with similarly primitive systems that can unfortunately succumb to the effects of lampricides. Species like stone cats, especially when they're spawning, lake sturgeon, mayflies, mud puppies, and other native lamprey species, as you know, American and northern brook lamprey. Often the chestnut and the silver lampreys aren't as common in systems, but it is a lampricide, unfortunately not a sea lampricide. And additionally, fish that are already stressed, such as those late in their spawning life stage, are also sensitive to the effects of lampricide. So while this is not desirable, obviously it's important to remember the extensive damage that a single sea lamprey can inflict, as Ross was explaining, if allowed to feed in the Great Lakes. So it's a trade-off, and the damage is, from not treating is far outweighs the unfortunate consequences of non-target mortality. Generally non-target mortality is minimal, but it's a factor that is continually monitored and we strive to minimize. There's a risk assessment unit. It's vital in the control efforts. They conduct surveys for non-target mortality after treatments. They report findings, implement measures to reduce undesirable effects. And one example, a notable initiative to minimize non-target mortality is the Save Our Sturgeon, the SOS program. So young lake sturgeon are particularly sensitive to TFM. To protect them, the U.S. Fish and Wildlife Service Risk Assessment Unit, in partnership with the Little River Band of Ottawa Indians and Great Lakes Fishery Commission, collect young sturgeons before treatments. These sturgeons are placed in holding tanks with their native stream water during the treatment, and then after treatment, they're placed back into their native habitat. 2023 in the Manistee River, there's an estimated 1.4 million sea lamprey larvae in that system, and many juvenile lake sturgeon were collected. It was a really good effort done by everyone. I actually went out on the boat at night and go out on these boats with spotlights, and you collect them by visually spotting them. It's quite an activity. Next slide, please. We'll talk about barriers. That's another essential method in controlling sea lamprey populations. They're designed to block the upstream migration of sea lampreys, disabling them from reaching suitable spawning habitat, like Ross mentioned, that rocky areas where they can build their horseshoe-shaped nests, etc. Sea lamprey barriers are constructed to deny the passage of lampreys, while allowing other species to jump over. So still maintaining some level of stream connectivity. Since sea lampreys are awful jumpers, a barrier with just an 18-inch drop is enough to stop them from accessing upstream areas. Natural waterfalls luckily often serve as barriers as well, where lampreys can't get past, and dams built for other purposes like hydroelectric dams do the same thing very often. So if there is suitable spawning habitat below a barrier, it significantly reduces the extent of the area needing treatment. So you could have a barrier a mile up from the mouth of a river, and there might be lamprey in there, but you'd only need to treat that mile as opposed to like 20 stream miles further if that barrier wasn't there. Next slide, please, sir. So kind of in conjunction with some barriers, traps are often placed to catch the spawning adult sea lampreys. Although trapping is not the most effective control method by any means, it's essential for determining sea lamprey population abundances in the Great Lakes. The trapped adult lampreys are collected for mark recapture surveys. They're used for outreach. I'm in Toronto right now at the Sportsman Show, and there's a tank of live adult sea lampreys that would have been caught in a trap, and the kids love to see them, and they are fascinating to look at, and also used for various types of research that Ross will touch on shortly. Next slide, please, sir. So this side, I know it's graphs, but just it shows the adult lamprey abundances in each Great Lake. It's a little dated, but they clearly demonstrate how effective sea lamprey control efforts have been at reducing the population since pre-control. You can see it starts off just way high, and then whoop, it goes down. If you look at Lake Erie, you notice a spike that resembles pre-control numbers from like about 2008 to 2012-ish. No one knows, it's kind of still a mystery what happened there. But sea lamprey numbers in Lake Erie are well below their target threshold and are doing quite well right now. On the other hand, Lake Ontario, the graph there does not reflect the recent spike in sea lamprey abundances. In 2020, there was travel restrictions, so there was no lampricide treatments happening, and really anywhere. There was a few local treatments happening near the stations that the agents work out of, but Lake Ontario had nothing, and the numbers went way up, and these traps were full of thousands of adult lampreys. So there's extra efforts focusing on treating Lake Ontario tributaries this year to kind of play catch up. So it's not, it's unfortunate. It's obviously not good that it happened, but it serves as an effective indicator of what would happen if treatment were to stop. And you stop for one season, and it takes years to play catch up. So it's interesting to look at that. There should be an updated sea lamprey abundance by lake graphs out on our website soon. Next slide, please. So all in all, I mean, the coordinated fishery management in the Great Lakes has been a remarkable success, as Ross mentioned, reducing the sea lamprey population by about 90% since the days before the control program. The achievement is regarded as the most successful integrated pest management program in the world, which protects the tribal and recreational and commercial fishery valued at about $7 billion a year. And one more slide, please, Ross. So the Great Lakes Fishery invests substantial resources in a program led by the USGS, the United States Geological Survey of Hammond Bay, known as SUPCON, which stands for Supplemental Controls. This program focuses on research and testing aimed at making control more effective in river systems where conventional lampricide treatments are less effective and extremely difficult to conduct, and often areas where it's just very hard to actually get to physically. So reducing the reliance on lampreycide is a future prospect that shows much promise and has already been effective in some streams already. Ross will go over some of those other supplemental control methods in the next slide.
Yeah, thanks, Zach. So so like Zach mentioned, the GLC is investing a substantial amount of time and effort into trying to find methods that can reduce our reliance upon lampreycides and barriers. One of the avenues that we have been successful in finding some progress on is through the release, the sterilization, and then further release of male sea lamprey. So this program was previously implemented in the 90s and early 2000s, but what was unsuccessful in actually reducing sea lamprey population numbers. So it was previously implemented in the St. Mary's River, which, as that kind of touched upon, is a huge river. It's a connecting waterway between Lake Superior and Lake Huron. And so what we found is that the sterile male release actually wasn't as effective in that system because there was that connection with those two lakes, and there was a lot of inflow of unsterilized males into that population. However, through this supplemental control program, what we've come to understand is that sterile male release works really well in areas where you do not have that high inflow and outflow of new lampreys into that population, and particularly with inland sea lamprey populations. So by and large, you really don't find a lot of sea lamprey populations on inland lakes here in the Great Lakes. In fact, as far as I'm aware, there are only really 2 in Michigan, and that's where we've actually tested and successfully done the sterilized male release. So the inland populations are limited primarily because of that sea lamprey's life history. So like we mentioned, they kind of need a larger water body to go out and to feed upon, and they need sufficient prey to kill those 40 pounds of fish, as well as sufficient spawning habitat. So substrate, like I mentioned, that rocky stream bed where they need to go to build their nests. So those are kind of the limiting factors that prevent sea lampreys from really reaching a lot of inland populations, but where they do have in Michigan, we've actually been able to utilize the sterile male release. And so what the sterile male release looks like is capturing the spawning males. So as I mentioned, they're going to run back upstream to spawn and die. So we're going to capture them, and then we're going to actually sterilize them and then re-release them back into the system. Of course, the sterilized males are then going to go and perform a spawning action with the female sea lampreys. Both will die thinking that they have produced fertile offspring, but in fact, no fertile offspring are produced. Another avenue that we've found some success in looking to other supplemental controls is through the use of pheromones. So sea lampreys are very much smelling organisms. So their nose, their nasal organ is magnitudes of times larger than their brains. So they're making a lot of their decisions based on smells. And so one of those smells that they make those decisions based on is what are called pheromones. And so pheromones are natural odors that are used to communicate between sea lampreys. So pheromones kind of come in 2 flavors. So you have attractant pheromones. So to attract, you excrete, a sea lamprey would excrete an attractant pheromone to bring other sea lampreys towards them. And so these attractant pheromones comes in 2 different types. So you have larval pheromones. So if you think about a sea lamprey that is out in the Great Lakes, it's done feeding on fish, and it's looking for a river or stream to go into. So as you kind of saw from that map earlier, there are thousands of connecting rivers to the Great Lakes. And so there are a lot of options for a sea lamprey to potentially choose to go upstream to find spawning habitat. But of course, they don't want to swim all the way upstream, spend all that energy, swim all those river miles, only to find that there's not suitable spawning habitat and they wouldn't be able to reproduce there because that would be a huge waste of energy. So instead, what they use is they're actually going to smell pheromones emitted by sea lamprey larvae that have already hatched from their eggs and are buried into that stream bed. Those larvae will excrete that pheromones. The pheromones will flow down from the rivers and streams out to the Great Lakes. And that communicates to the adult sea lampreys that are looking to spawn that there's suitable spawning habitat in there, that there are offspring sea lamprey larvae in that stream. And so therefore there's suitable spawning habitat so they can go ahead and come right up and spawn. In addition to that, there are also sex pheromones emitted by male sea lampreys. So the male sea lamprey, when they're going upstream to spawn, what they're going to do is they're going to be the ones that kind of build that nest. And then once they build that nest and they are ready to spawn, they're going to excrete a sex pheromone that's going to tell the female sea lampreys that they're ready to go ahead and lay those eggs. On the opposite end of the spectrum, you also have repellent pheromones. So these are kind of like fight or flight pheromones. So these are given off by dead or dying sea lampreys to let other sea lampreys in the area know that there's a predator nearby and that they need to leave because there's a chance they might die. And so the idea with the discovery of these pheromones is that we have the potential to improve trapping. So like Zach mentioned earlier, the trapping is used to assess sea lamprey populations, but is not efficient enough to where it's actually decreasing a substantial amount of the sea lamprey population. So it's not a control method per se. It's more used for our assessment purposes and for obtaining live adult sea lampreys. But with the idea of, with the hopeful implementation of pheromones, the idea is that maybe we'd be able to improve the trapping efficiency of those traps, in turn trapping now into a suitable control method. And then one other avenue that we've made some recent progress in terms of pheromones is actually the discovery of what are called pheromone antagonists. So these are essentially act like chemical nose plugs, where they're going to, when applied in the rivers and streams, they are going to actually act like chemical nose plugs and prevent female sea lampreys from being able to smell the pheromone emitted by the male sea lampreys. So even though a female sea lamprey may be in a river or stream where there is a nest built, by applying that pheromone antagonist, what we've been able to find in the limited trials that we've been able to test it in is that the females are unable to find those streams, or those nests, and reproduce. So, so these are all pheromones that we've been able to synthesize and test in the lab. The longer term implications, of course, are that we will need to do further testing. So while it may prove useful in the lab, we will need to be able to use it on a wide scale basis. What we need to be able to do is produce it on a cost effective basis and ensure that it'll work in all kinds of environments. So one of the pheromones that we've been able to synthesize is what we call an alarm cue. So that's a repellent pheromone. So if you take a look at this video here that I'm going to play, the researcher here is going to dump in just a small vial of that alarm cue. And like I mentioned, what that pheromone indicates is a predator nearby, a fight or flight response. And take a look and see just how visceral of a reaction the sea lampreys in this tank have. So as you can see, pretty visceral reaction, right? And so like I mentioned, that smell indicates a fight or flight response, that there's a predator nearby. And so the idea is that if we are able to produce it on a cost-effective basis, that we could apply it in areas, in rivers and streams where we don't want sea lampreys to go, and actually discourage them from going to, say, where there's prime spawning habitat, and encourage them to move towards areas where we, say, have traps. And so what we've actually discovered in some of the field trials of these pheromones is that the alarm cues are effective, but only in a small amount of time. So similarly to how you might light a candle in your house, and then after, say, like an hour, you kind of don't smell that candle anymore. The same thing holds true for sea lampreys. So while we can apply that alarm cue initially, and they'll have a very visceral reaction initially, if we were to, say, continually apply that alarm cue for an hour, they're only going to react to that for maybe 1 or 2 times. You know, once that continues to be applied in the stream, they're going to kind of get used to that. So that is another implication in terms of the feasibility of using alarm cues and other pheromones, incorporating those into our control program in the future. And so we have give ourselves about 3 more minutes before we take some questions. I quickly wanted to talk about the early days of control, because I think that I personally, when I started here at the Great Lakes Fishery Commission, I started working on a oral history project, so I'm very well versed in the history of our sea lamprey control program, and so I always think it's really cool to go over that, so I'll briefly touch on that here. So when sea lampreys first invaded, like I mentioned, they were very destructive and were killing the economically important fisheries of the day, so they're very desperate to find a way to control them. And so one of the things that they tried, one of the many things they tried in controlling them, was actually eating sea lampreys. And as you can tell by the look on this guy's face, sea lampreys were, by all accounts, gray, disgusting, not very appetizing, and very much did not take off as a food fish. And searching for control methods, what the scientists ended up first starting with was essentially just using fences, barriers across the stream. And so while these barriers were great because they prevented the sea lampreys from going upstream to lay their eggs, they were, of course, not selective. So they were great at blocking sea lampreys, but unfortunately were also good at blocking other species as well. Of course, as well, anytime there was a high water event or a storm, those barriers were oftentimes just wiped away. So while effective in maybe the later days of spring after the rains have come, in the early days where you might have high water events, flash floods, they tended to be less effective. Eventually, the physical barriers were kind of morphed into electrical barriers. So you can see these were electrodes that were hung all across the river. You can see it was a little precarious to kind of get these things set up. Definitely some OSHA violations going on here. But again, I think that goes to showcase how desperate people were to find an antidote to the sea lamprey poison, to be able to control sea lampreys and really restore the Great Lakes fishery and the Great Lakes economy. So these electrical barriers, again, much like the physical barriers, while they were effective in blocking sea lampreys, of course, were not selective. And so oftentimes you would, again, end up with killing native species as well. Eventually, the research for a control method turned towards the use of chemicals, and that's when we discovered TFM, the pesticide that we use today. So what that looked like is that the research scientists up at Hammond Bay Biological Station in Millersburg, Michigan, what they would do is that they would run all these what are called bioassays. So in each of these jars, they would put 2 native fish species, a trout and a bluegill, I believe, and then put in a sea lamprey larvae. And then they would take any sorts of chemicals and dump it in there and just see what would happen. So they did 5,209 of these bioassays before they found TFM. And as you can see, the person that was collecting data here and doing these bioassays, he kind of, when he saw that the TFM killed the larval sea lampreys but left the native species unharmed, where he was supposed to write the data, he just wrote special, and he kind of knew the weight of the discovery that he had just found. So if you want to learn more about the discovery of TFM, as well as just a more general discussion of the involvement of our sea lamprey control program, I would highly recommend checking out a book written by my former colleague, Corey Brandt. So it's called Great Lakes Sea Lamprey, the 70-Year War on a Biological Invader. So in that, this whole book is informed by a multi-year history project. So for, I believe it was 3 or 4 years, Corey went around and he interviewed a number of different people that were around the Great Lakes back when the sea lampreys first invaded. So he talked to people that were in commercial fishing families that were operating commercial fishing operations when the sea lampreys invaded. He talked to people in the sea lamprey control program back in the early days about what it was like trying to find that silver bullet that eventually came with TFM. It's a very, very interesting read, and if you're interested in learning more about our control program, I'd highly recommend checking it out. And with that, Zach and I can take any of your questions. Thank you so much for your attention, and look forward to answering your questions.
Ross, Zach, thank you for that presentation. I was hooked the entire time. Yeah. My God, nature, what are you gonna do, right? Like, wow. I really enjoyed looking at those photos. Really shows, well, underscores the subtitle of the book that you plugged, the 70-year war against this species. That was, wow, really puts things in perspective how long they've been here. I believe that they entered Lake Ontario, was it like 1899 or something? I'm
Even
not
earlier than that, yeah, I think
really.
the official year might be like 1833 or something.
Yeah.
So I think it was about 90 years between when they were in Lake Ontario and then that Welland Canal was widened and deepened that allowed them to bypass the falls. So
That'll do
like
it.
Zach mentioned, natural barriers like waterfalls often help
Hmm.
us in blocking sea lampreys, and that was
Hmm.
one of the first examples of that is Niagara Falls. So, but
Mm,
unfortunately, as with many invasive species,
yeah.
it's all man mediated, right? It's the movement of us, the movement of goods,
Yep.
services,
Yep.
the need for the economy.
Yep.
That kind of is the cause of many of these invasive species.
Yeah, sure. I see. Um, well, all right. All right. Well, I've got a good number of questions for you guys. We also have some questions popping up in our chat. Um, yeah, within the context of how man-made structures facilitate the movement of invasive species, somebody asked, have you ever evaluated potential dam removal projects in the context of stream restoration benefits versus the loss of the Lamprey barrier for them to move upstream?
Absolutely, and so that's actually a key thing that oftentimes people don't think about. In conservation, there is really that push now towards reconnecting stream habitat, right? We want
Hmm.
to be able to reconnect historical habitat, allow these fish to really reach their historical spawning grounds, which is great because we can remove a dam and that allows the native fish species to pass by. But of course, the
Hmm.
other side of the coin is that you open that up to invasive fish species as well, like the sea lamprey.
Yeah.
Um, and to kind of try and address that, we are actually, the GLFC, in partnership with the city of Traverse City, we're doing a very interesting project called Fish Pass. And so what that is going to do is there's a dam that it's the first, what we call the first blocker. So it's the dam that is closest to the lake and acts as the first blocker of invasive species. And
Yep.
so what we're doing is we're going to replace the dam, but then just downstream of that, we're also going to put in an experimental fish sorting channel. And so with that experimental fish sorting channel, what we're going to do is we're going to investigate ways to passively sort fish. So, we mentioned trapping earlier, which is great because, we can selectively, remove sea lampreys and pass native fish species, but of course, requires a lot of time and effort and money. And so the idea with this fish pass and this experimental fish sorting channel is that maybe there's a way that we can discover ways to passively sort invasive species from native species. So
Yeah.
looking at things like acoustic deterrents,
Hmm.
bubble curtains,
Hmm.
lights, AI, things like
Yeah.
photography, where you take a photograph and the AI can
Sorts it.
recognize whether it's invasive or native
Yeah.
species and then sort it based
Hmm.
on that. So no, it is absolutely something that is on the top of our mind, and
Yeah.
we're most pertinently addressing it through that program. But it is, of course, yet there is almost every year requests to remove dams, and we are very much on top of that, working with those dam owners as well as the local stakeholders to kind of point out the cost and benefits. That we obviously we are on that side too. We want to restore stream habitat, of course, but of course we want to make sure that we're just not opening it up to new sea lamprey habitat as well.
Yeah. That's one heck of a trade-off there. And
Yes, absolutely.
Indeed, it is.
yeah, has there been any actual recorded instance of streams being invaded by sea lampreys that didn't have access before, but now do because of dams being removed?
That's a good question. I can't think of any off the top of my head, no, but there are often, this year there are, not having to do with dams, but there are always new streams popping up with sea lamprey larvae.
Really?
Definitely. So there's like a few new treatments on the on the schedule this upcoming field season.
I suppose that really just underscores the sea lamprey's resiliency and their ability to colonize new habitats, and how this population quickly changes with the times.
Absolutely. I did want to mention that Ross mentioned, they they sense where there are larval sea lampreys in streams. It's a signal to that's a good habitat, but it doesn't actually have to be sea lamprey larvae. They'll also use native lamprey scents to do the very same thing. So they don't necessarily return to their natal streams. They can inhabit any spot that smells good to them.
Yeah. Wow. That's something. Okay, somebody had a question on trying to minimize the harm of non-target species with these lampricide treatments. So given that mud puppies have a high sensitivity to TFM and are a host for federally listed salamander mussels, what measures are taken during treatments to prevent mud puppy mortality?
Right. So right now, that risk assessment crew that I was talking about, they are kind of on the forefront of researching what to do about that. We're not quite sure how to do that. I know I would assume that the smaller the size of the mud puppies, if there's like a heavy larval population, they might defer to a later date. But yeah, it's still up. It's still in question. It's still being researched right now. It is a priority for sure. It's a good question. I wish I had a better answer.
Yeah, I know that's fair. And like it just based off your presentation, it seems like a lot of the energy now, a lot of resources are being invested into other alternatives to lampricide treatments. Out of all the ones that you both listed, involving the pheromones and I got them here somewhere in my notes. But anyways, I was wondering which ones do you see are the most promising that could be used on an ecosystem scale level in the whole Great Lakes Basin?
That is and maybe I'll let Zach provide his opinion as well. But it's hard to say right now because I'd say the sterile lamellar release, it's hard to answer specifically on an ecosystem scale. I think realistically what's going to come is that we'll find a variety of these alternative control methods, these supplemental control methods are going to be effective in very specific contexts. So like I mentioned with the sterile lamellar release, so we found that's really effective on inland lakes, for example. And like the pheromones, for example, it is proving promising, but we still need further research to take that next step, right? So even though we've been able to synthesize it in the lab, what we found is that alarm cue, for example, is very expensive to synthesize. And that we know that, like I mentioned, you can't just pump it for days straight, they'll get used to it. And so it's hard to say right now how I'd say that what I kind of said earlier would be kind of my guesstimate that is that there won't be one single one that is the new TFM, for example. I think you're going to see just kind of these different methods used in piecemeal actions. There has been research investigating more kind of lucrative control options. So for example, looking at things like, if we altered the DNA of sea lamprey and we're able to do such that they are going to ever so slightly produce more male offspring versus female offspring, then it's just hands off and they'll drive themselves into extinction after how many generations. Of course, that's a much more involved control method, and it opens up a whole ethical can of worms in terms of altering something's DNA. But yeah, I'd say that's probably that would be my guess. But I'm curious, Zach, if you feel anything else.
I totally agree with you. I did want to mention that they are also the USGS also is always researching new forms of lampricide, and there is one to be tested this field season called SC. I'm not sure what it stands for, but it just might be better in a whole ways. We'll see what happens for sure. But I find it just promising and comforting to know that it's not just okay, we're done, this is good enough. Like there's always lot of resources and money and time and expertise put into trying to come up with new and innovative and safer ways of doing the treatment.
Right.
But as long as there's that adult population or that parasitic juvenile population rather out in the lakes feeding, you can't get to all of them unless there's some magic formula to take care of it all, but that just doesn't exist.
Yeah, sure.
Yeah. And then I'd also add too, in terms of the lampricides, we're also looking for resistance to the lampricides too. So we actually just held a workshop here in, I think it was November, all focused on, well, is there a possibility of sea lampreys evolving resistance? What happens if that does? And what does that look like? So even within the lampricides, we are, like Zach said, it's not like we're just kind of sitting on our hands and content with where we're at. We are always looking for cutting edge research, the best way to be doing our program, the best way to be controlling sea lampreys and helping promote a healthy Great Lakes fishery.
Yeah, I mean, I think personally, I think you guys are approaching it the best way you can, at least when it comes to dealing with such a resilient, such a resilient species as the sea lamprey. And even though there doesn't seem to be a one size fits all control method for this species, at the very least, it's better to have more tools in your tool shed to know how can control practitioners minimize the harm that they cause to local species and to communities living in the watershed. It seems to me that just more tools in the tool shed is a good thing. So
Absolutely.
we did get more questions in the chat, and Ross, I actually think you alluded to the subject of this one. Has any resistance to TFM been observed, and if any, at what frequency?
Yeah, so as far as I'm aware, I don't think there has been any. I do know there is, I mentioned that workshop. I know there is a specific project investigating sea lamprey resistance. And so what they did in the lab was they took sea lamprey larvae, exposed them to pesticides, the lampricides rather, and then went and looked at the organism, the lamprey that, the larvae that first died and the larvae that lasted the longest. And I believe what they're doing is they're looking at their the DNA, the genetic structure there to see what differences might lie there and if that could be a precursor to resistance. But as far as actual involved resistance, I don't think there's been any observed out in the field or in the lab as far as I'm aware.
Okay, that's fair. I mean, at the very least, you guys are having like workshops discussing at least the possibility of eventual resistance being evolved. I got you. Okay. So I was wondering, how much does this sea lamprey control program cost the Great Lakes Fishery Commission annually? If you have like exact numbers or estimates.
I believe it's about 28 million. Is that right, Ross?
I'm just pulling up our budget sheet, and I can tell you in just a second. But yeah, so I mentioned, there are other parts of our program, or other parts of our organization, right? So in addition to sea lamprey control, we fund science, we coordinate fishery management. So the sea lamprey control program is a majority of our budget. And I will tell you the numbers here momentarily.
Sure.
Let's see. So we get funding from both the U.S. and Canada, and so of the, I'm just pulled up the Canadian request, and that's going to be of the 19.6 million that we are requesting from Canada, about 13 million of that is going towards sea lamprey control. So and it's going to be the same over in the U.S. as well. That will request, I think it's like 60 million or something like that. And then again, a majority of that's going to go towards sea lamprey control, because even though that TFM is very effective, it is also extremely expensive. And like Zach was talking about, all the time that it takes to properly do a lampricide treatment to make sure we're doing that with no to little non-target mortality, it takes a lot of time and effort. So it is most of our funding does go towards that sea life control program.
Sure. Yeah, I was mainly wondering because I wanted to understand how much of a financial investment this program is compared to the entire Great Lakes fishery. I remember in our initial discussion about this webinar, like you were just shooting me some numbers about the Great Lakes fishery, how it's like worth something like $7 billion a year.
Yeah.
So 30 million a year to keep this fishery from more or less collapsing due to one invasive species. It sounds like a great investment.
Absolutely, man.
Yeah, and then I think it's also interesting too is you think about in today's hyperpolarized environment where you can't get anyone to agree on what the color of the sky is. You've seen we have seen very regular and very consistent investment in the Great Lakes Fishery Commission from both the U.S. and Canada. So we have seen our appropriations being met, if not increased, year after year. And so I think that underscores not only that the Great Lakes fishery is an issue that spans the aisle and spans all ideologies, right? Everyone is happy for the Great Lakes. The Great Lakes affects everyone, and is a resource shared by both the U.S. and Canada, and is treated as such. Absolutely.
Mm-hmm. Yeah. I'm very encouraged and frankly just happy that the issue of the health of the Great Lakes ecosystem and funding for programs such as the Great Lakes Restoration Initiative is bipartisan. It has been bipartisan for quite some time. And I understand that there is currently a bill in Congress to renew funding for the Great Lakes Restoration Initiative for, I believe, the next decade. Though I personally don't follow updates along those lines. But to your point, it's great that we have a bipartisan support for the health of this region. Speaking though about the future though, I was wondering, how do you see climate change impacting the effectiveness of these sea lamprey treatments and from a broader standpoint, the ecology of the sea lamprey and how that might change over the century? Like, what are your thoughts on that?
It's a really good question. I couldn't speak so much to the ecology, but I could speak to what it looks like for the control program. And it's, for instance, this year is obviously strangely, bizarrely warm.
Yeah.
So we're looking at into a couple of treatment supervisors from DFO last night, and it's looking like a very strange year for sea lamprey control. There might be, if it continues on this path, there might be not enough water to treat anywhere.
Really?
For sure. And then you're also looking at, so TFM, if it loses its efficacy at 6 degrees Celsius or below, the waters are
below.
Or below that. Yeah. So when it gets too cold, it's not effective. But as warming happens, and there are rivers that are warming up a lot quicker than usual, that could mean treatments in the winter someday, perhaps, things like that. And with with the intense climate change weather that experience the more volatile weather systems, and you get heavier rainfalls and storms, and that affects systems in all kinds of ways. That, like I explained before, the pH will go up, down, and this and that, and if it's like a model, it can't be treated. So that's hugely being looked at, and it's a concern right now for sure. It's a really good question. As far as ecological impacts, I couldn't really speak to that, but Ross might be.
Yeah, I'd say ecologically, and again, I'm not super well versed on the physiology and the intimate details of the sea lamprey's ecology, but like Zach mentioned, with warming waters, the water temperature is kind of be the green light for sea lampreys to start running up into rivers and streams. So at the very least, you're going to see the spawning season move earlier and earlier, assuming the waters do it's consistently warm. But I think kind of like what Zach mentioned, I think it's important to keep in mind that climate change doesn't necessarily mean warming, right? probably
Yeah.
means more variability and higher frequency of more intense storm events. So I agree with everything Zach said that, with those more intense storms, that really might just make it more difficult to get consistent stream conditions and favorable stream conditions for lampricide treatments.
Yeah, sure. Zach, when you were listing off all the environmental parameters that need to be just right for TFM treatment, my first thought was like, geez, if our changing climate with the increased variability as what you were referring to, I just am wondering how often or less often will these conditions align to actually allow TFM? So. I mean, I'm just like wondering myself, like, I wonder if as like the Great Lakes Fishery Commission is investing in these new methods to combat sea lamprey. I believe you mentioned some sort of pesticide. I forget it. I forget the name. It had 2 letters in it. But anyways, I wonder if it requires small parameter, like small windows of certain parameters or something like that.
Right. Yeah, it's tricky because it's so dependent, and every watershed's so different. The chemistry is so different. The flow, the species there, the substrate, everything there. But it is it's a good thing to think about, absolutely, because all
For
those
sure.
parameters can, like we've been talking about, be super effective. Maybe it makes treatments more stable and doable. Who knows, right? Maybe it makes them you do all season reliable because it's warmer, but too warm, and there's consistent, and that would you'd be able to cover like kind of a all year field season. But on the other hand, it could narrow it down to these little windows of ideal opportunities. It could limit a lot. But it's it's really important to think about, and it's a really good question.
Yeah,
Sure.
I'm glad that you two on the team are thinking about this as we move forward in this year, this decade, and this century. But yeah, fellows, I had 2 more questions about the ecology of the sea lamprey, and then after that, I was hoping we could wrap up if that's all right with you guys.
You bet.
Awesome. So Ross, just to circle back to the discussion about hang on a second, I'm trying to find the right section of my notes. The sterile male release treatment. You mentioned that it has only been tested in inland lakes within the Great Lakes system. I was wondering, have there been any studies on the efficacy in streams and tributaries that lead into the lakes, and whether those trials might be expanded or done soon or anything like that?
Yeah, so, and I think Zach would also be able to touch on this as well if I am missing anything here, but essentially, as I understand it, the emphasis on the inland lakes is primarily because we had tried it on like I mentioned, the St. Mary's back in the 90s and 2000s. And what they found is that in order for the sterilization to work, right, is you need to have a high proportion of the sterilized males compared to the non-sterilized males. So you have a larger proportion of the population quote unquote reproducing and then not actually producing fertile offspring. And so the problem with doing it with just your Joe Schmo connecting tributary to the Great Lakes is that you have no ability to limit the inflow or the outflow of new sea lamprey populations. So you might go and you could sterilize, say, 20 sea lampreys, but then if it's, if you know that you still have connection to the Great Lakes, then, I mean, you can go and re-release those 20, and then you have another 200 that come in, and then your proportions are way out of whack. Whereas in inland populations, or inland lakes rather, on those populations, you're not really getting as much inflow and outflow of the population. It's pretty stable compared to what you might find on those other connecting tributaries. And so as far as I understand, that's kind of the reasoning there, is that you really aren't going to get as much of a stable population in other places around the Great Lakes. It really is, you kind of need very specific conditions for that.
I see.
It's kind of a nice little controlled environment to test that, where you can, you're not overwhelmed with the influx of migrating sea lampreys. We kind of have a handle on the population. I think
Yeah.
like in the Sheboygan River system, those inland
Yeah.
lakes,
Yeah.
there's been success with that for sure.
Do you know how successful?
Don't know to what measure, but Ross
Sure.
might be able to. But
Yeah, so it's the, Zach mentioned that supplemental control initiative. So that's a 10-year program,
Yeah.
10-year study essentially. And so,
10 years.
and so we're unfortunately, I don't get to go out and hang out with the biologists and the scientists that are doing this research.
Yeah.
And so I do not know the specifics of how successful that is, but
Yeah.
I do know there has been making some headway, some success, absolutely.
Sure. Yeah, that's cool. Yeah, I mean, I get it. Yeah, it's the proportionality that matters the most. And if you're having unaffected male individuals entering into the study, well, then your study's compromised. I mean, like, yeah, I'm not at all involved in this study, but I would imagine that at least based off of the preliminary data of where this works and where this kind of doesn't work, it seems that if we're ever going to use this on a Great Lakes wide scale, it's got to be happening everywhere all at once. And I have no idea how expensive that is. So,
Yeah.
I mean, yeah, I mean, at least these efforts are still continuing. The research is still happening, and this shows promise.
Yeah.
Yeah.
Agreed.
So I had one last question. Not exactly related to sea lamprey control, yet merely how they're interacting with the Great Lakes ecosystem and the species that are here. So are you two aware of any species already here in the Great Lakes that hunt sea lampreys?
An interesting question. No, but there are notions that, and in Lake Erie, it is thought that perhaps walleye, certainly when they're a little smaller, the parasitics are smaller, that they might chomp on them. That is totally possible because they aren't the natural, prey species. So no species is like specifically targeting them. But if you have a little transformed larva heading out into the lake, it's just a wormy-like thing.
Yeah.
They might be catching onto that to some degree. It's hard to know, but that has been suggested, and that would be cool if that were the case for sure.
Yeah.
Right. Yeah. And that I don't think there's been any evidence to suggest that there's necessarily like a predator-prey relationship. Like maybe walleye will feed on the larvae, but most of the time it's probably gonna be opportunistic. And I think and to a more general scale, it's difficult for an ecosystem to rebound like this, right? Ecosystems evolve. If you think about the food web, there's just enough predators for just enough prey. The populations of predator and prey keep each other in check, right?
Yeah.
And so when you have an invasive species that comes in that is not part of this thing that's evolved over thousands of years, it takes a long time for an ecosystem to rebound, right? So so it's nothing at the moment, opportunistically, but definitely something we'll be keeping an eye on. They did some of those early control methods that I talked about. One of the ones that they tried was stocking American eels. They I don't remember what the specific reasoning they thought American eels were the go-to, but they did at one point try and stock them, but of course that did not yield any positive results.
Maybe there's some natural predation, that predator-prey relationship in the ocean. I'm not sure.
Yeah,
maybe
sure.
They mimic that relationship, maybe.
Well, we tried.
Yeah.
Yeah, that's really fascinating how like there are elements of the ecosystem which are showing possible signs of adjusting to their presence. I mean, Zach, I don't know if you said that it was confirmed that walleye are now feasting on these larvae, but anyways, what I was trying to say was that ecosystems, they're self-organizing systems, and invasive species is like throwing like a wrench into the machine, and it I mean, engines, they don't adjust, but ecosystems, they do, and they change and they evolve over time of what's happening inside of them and outside of them. So in fact, like the what is it called, the Lake Erie water snake, it's a subspecies of like a water snake. I don't know the exact name of it, but anyways, I know that nowadays one of its main food sources is this invasive fish. I don't know what species it is. Just somebody within my field told me, yeah, they now mainly eat invasive fish. And I'm like, that's cool, and they're still here, and they're just adapting to the new changes. So
I can say that gobies, for example, in Lake Erie. I mean, I grew up on the North Shore of Lake Erie.
yeah,
Back when gobies were kind of the new invasive species in that area, and we'd catch them and we'd have to stab them. But it's to a point where they have turned into food for native fishes like smallmouth bass. And they model lures after gobies now, like tube jigs are the goby.
wow,
They've kind of integrated as a, this is still an invasive species, still not good, but
yeah.
yeah, but the sea lampreys are different. They're so prehistoric. Like they're so resilient and intense. They've remained unchanged for over 350 million years. They've survived at least 4 extinction events.
350 million years.
They're living dinosaurs. They're way older than dinosaurs.
Wow, that's cool.
It is they are fascinating for sure. And they're great in their native habitat. Just where the Great Lakes, I'd be a much bigger fan of them for sure.
I appreciated the first couple slides showing how the sea lampreys are celebrated and involved in cuisine in their native habitat. I believe you said it was the Black Sea, somewhere in the Mediterranean.
So yeah, so their native range of the Atlantic Ocean, and then over on like the west coast of Europe is where the sea lampreys specifically are very valued as a food fish. In fact, there is
We don't like them.
but the monarchy over in England, there's a traditional dish, a lamprey pie, that was made, I think, most recently in 2015 for the Queen's Platinum Jubilee or something like that. And we actually sent lampreys over for the lamprey pie. And again, I've never had lampreys. Don't think the pie would be the form factor that I'd want to have them in, but maybe I just haven't tried it.
I would love to try sea lamprey pie. I mean, they're there, and I've heard that they're actually endangered in their native habitats.
Yes,
which
so that is ironic. Yeah, is that so we're trying to get rid of them here, and of course we're trying to conserve them in the native habitat. And we talked about dam removals, and that's one of the big reasons that they are they're endangered, is that they need to reach that specific spawning habitat, and they're unable to because dams prevent them. So over on the east coast of North America, as well as over in the Pacific Northwest, with a lot of the Pacific lampreys, there really is the push towards to reconnect habitat and remove dams for the purpose of restoring lamprey habitat. Yeah.
Well, I think that really just underscores the point that these species, the invasive species, they're not inherently bad. Like, the reason why they're here is because we brought them here, and it's given all the havoc that they've caused in this ecosystem, which they just haven't evolved to be here, and they don't belong. It's our responsibility to not only our economy, but to the fisheries and all other non-human beings that live here, that we right this wrong. But yeah, guys, thank you for coming out and presenting, by the way. And if it's all right with you, I think we're ready to wrap up pretty much.
Sounds good.
Yeah, thank you. Thanks to you, and thank you to everyone for the wonderful questions. It's always great to go deeper and talk with folks and really get into the nuts and bolts of the sea lamprey issue here in the Great Lakes.
Yeah,
definitely. Chris, if you had any other questions after the fact, or you're later thinking, email Rob and I, and we can certainly, if we don't know, we'll do our best to find out some answers. Yeah, something that we're not familiar with, for sure. We have some good contact. Yeah.
Okay. All right. Well, Ross, Zach, thank you for coming out, guys. I really enjoyed the conversation. Presentation was great too. And to the attendees, I'll be uploading this video to YouTube in the coming days. Send out a follow-up email with a link. And well, thank you for coming, everyone.
Great. Thanks, everyone.
Thank you.
All right. Take care, everyone. Bye.
Have a great day. Now how to get off here, I don't know, Roz.
Yeah, right? That's what I'm trying to.
I'm not familiar with
Can I?
I'm not familiar with the.
But yeah, go to webinar.
Nice job though, buddy.
Thanks, you too, man. And I kind of figured that there would probably be someone come up and ask about the mud puppies.
Mm-hmm.
Okay,
Yeah,
here we
no,
go.
it's interesting. I'm gonna find out some more information. I'll probably give Cheryl an email and really
Yeah,
have an answer for that because it's important.
yeah, especially with the mud puppies. I mean, I think that yeah, I think you gave a good good answer to that. So yeah, I'll be interested to hear what you find out. But all right, I think I found out how to leave. So if you go to File, Exit, Leave Webinar.
Got it.
Yeah.
Awesome.
All right.
Thanks,
See you.
Talk to you soon.